Okay, a little while back we used a one proportion z interval to test a claim about a proportion using an interval. Today we are going to use an interval to test a claim about a mean. Okay, so there's a couple of quick caveats that have to be put in place here. One, just like the interval test for proportions, it can only be used in the two-tailed situation. And two, because it is a mean and we cannot assume the standard deviation of the population from a sample, we have to do this using the t-distribution, so we're going to use the t-interval. Alright, all of that, let's say we have a claim. Alright. And our claim is that the average American family, or in American, let's say it this way, American families on average, there we go, that's a better statement, have 2.5 children. So the average number of children that an American family have is 2.5. Like, no family has 2.5 children. That doesn't make sense. But if the average number of children that a family has is 2.5. So we can break this into a null hypothesis and an alternate hypothesis. The null hypothesis says mu, the mean, is 2.5. Since this is an equivalent statement, the alternative hypothesis has to be that the mean is not equal to 2.5, and because of this, this is a two-tailed test. Okay, so we say somebody goes ahead and takes a sample of 100 American families, and that they find from that sample that the average in the sample was that they had 3.1 children, and the standard deviation of the sample is 2.1 children. So the mean of the sample, x bar, is 3.1 children. S, the standard deviation of the sample, is 2.1 children. Okay, so this is all the statistical information that I need in order to create a t-interval. So let's get out the calculator. Okay, so I have my calculator, and I go stat, test, and I want a t-interval. So I'm grabbing number 8. I am feeding into the statistics, not data. So I go to stats. The mean for my statistic was 3.1. I had a standard deviation of 2.1 and a sample size of 100. We're going to keep the confidence level at 0.95, and we are going to calculate. And this is my confidence interval. So I am 95% confident that the mean of the population has to be between 2.68 and 3.5. What is not on that interval of 2.68 and 3.52 is 2.5. So let's finish out our hypothesis test here. Okay, so the t-interval that I got from this sample was that the mean had to be between 2.68 and 3.52. So if I look at my null hypothesis, I should reject this because that is not on the interval. So I'm going to reject the null, which means since the null is the claim in the two-tailed test situation, I say that the data does not support the claim. And there you go. Using a confidence interval to do a hypothesis test about a mean, It's about as simple as it gets. Remember that this only works for the two-tailed test. And because we don't know the standard deviation of the population from the sample data, we have to go with the t interval to make this happen. All right, so there you go.